See here, properties of inverse function. So I am going to explain the points yesterday which I wrote. That points I'll explain. Right? The first point, what was the first point? Properties of inverse function. Inverse of a bijection is unique. Reflection. See here, inverse of a bijection is unique. Meaning is what? Suppose you are taking here. Suppose 0 to 1 it is mapping. 2 to 3 it is mapping. If this is a bijection function, then inverse of this will be unique because 1 will be mapped to 0, 3 will be mapped to 2. So this mapping is unique, no? It will not be different. Suppose you have 0 comma 1, then you will be getting 1 comma 0. So inverse means if you have a point 0 comma 1, then inverse will be 1 comma 0. That is the first point. Second point is for which is to be invertible. A function is to be invertible, it must be bijection. I already informed that. If any function is invertible, then the function is bijective. Point number 3. Inverse of bijection is also bijection. Inverse function जो होता है ना, inverse function. That function is always bijection. Okay, it will satisfy 1, 1 and onto. Inverse function will satisfy 1, 1 and onto. So inverse of a function is always bijective. Okay, then only it will become the inverse. Otherwise how? Right. So point number 3 over. Point number 4. What is the point number 4? The graph of f and f inverse are the mirror images of y is equal to x. I informed this also. See here, e power x is exponential function graph is like this. Logarithm function graph is like this. So these both functions are mirror images with respect to y is equal to x. Any function you take, then what happens here? If I take here, this point is 1 comma 0, then this point will be 0 comma 1, then this point will be 1 comma 0. Okay, so the mirror image about which y is equal to x line. So you will learn in straight lines for any point what is the image of a point with respect to a line. So that time you will get more clear picture. Okay, so what I want to say here, if a function is there, inverse function is there, then these two functions always the mirror image about y is equal to x line. Okay, y is equal to x line, they are mirror images. Next point is what? Point number, another one. Normally point of intersection of f and f inverse lies on the straight line y is equal to x. Point of intersection of f and f inverse. Suppose these two are not intersecting, but two inverse functions are there. Suppose any x square and root x I am taking. What is the graph of x square? Graph of x square is like this. What is the graph of root x? Root x will be like this. But x square is not one function. But if I restrict the domain positive, then it will become invertible. So you can see that if this is a x square graph, okay, and I restricted the domain positive, okay, and is a root x graph. So then these both are, you know that they are inverse to each other. X square inverse is root x inverse is x square. And if you see this, if you join this line, they are going to intersect at the line y is equal to x. At this point, they both going to intersect. That is the point it is written. What is the normally point of intersection of f and f inverse lies on this line. Point of intersection, here it is intersected, here it is intersected. Then these both are lying where? This point is lying where? Y is equal to x. These are the both curves, these are inverse curves each other, but they both are intersecting, and that intersecting point lies on y is equal to x. That is the point. Next, what are the point? Next you have a function R, see, functions are not generally 1, 1 and onto functions, but to make them invertible, we redefine the function. Already I told you sin x. See, sin x is not invertible, right? Sin x is not invertible, but to make them invertible, we restrict them. X square also not invertible, but if I restrict them, then it will become invertible. Like if I want to say, yesterday I told no sin x. If you say sin x graph of sin x will be like this. This is the graph of sin x. So this is not invertible because it is not 1, 1 only. But if I restrict the place, I redefine them. If I redefine for a particular domain, then this place it will going to be invertible. Means any function, generally all functions are not invertible. That is main criteria you want to say. Generally all functions are not invertible. But if we want to make them invertible, we can redefine them. If we redefine them, then they will become invertible. That is the point. Understood, na? Understood what I said? And next point is sixth point. Sixth point was f of x, g of x are inverse functions each other. F of x, g of x are inverse functions each other. Then what they given? F dash of g of x will be equal to 1 by g dash of x. This is what they give, right? So see, I just say f of x and g of x both are invertible functions. Then f circle g, if I write f circle g, and this is f circle g, I am going to differentiate here. If you differentiate a function now, what do you get? So if you differentiate, you get f dash of. If you differentiate this, what I get here? F dash of g of x. Again you have to differentiate inside function also. Then g of x also it should be means f of g of x. If I differentiate this, okay. So what I get here? G dash of x. G dash of x I get now. So f dash of g of x will be equal to what here? F dash of g of x will be equal to f of g of x by g dash of x. है ना? समझ में आया नहीं है? Okay, एक minute, let me leave. If f of x, g of x are inverse functions each other, okay, inverse functions each other, then okay. See, f of x. Point is clear now. Point is not like this. I'll just tell you. This point is also right, but what they have told, I tell you. Two functions are inverse. Two numbers are inverse to each other. Like if you know, if I take a number, if I get 1 into, suppose 2 into 1 by 2, I get 1. Can I say 2 and 1 by 2 are inverse to each other? 2 or 1 by 2 are inverse to each other. Is it right or wrong? Now if I write 2 plus minus 2 is equal to 0, can I take 2 and minus 2 inverse are each other? Are 2 and minus 2 inverse or not? Yes. Yeah, additive inverse hai na? This is multiplicative inverse, which you have learned in 9th and 8th. These are what? Additive inverse. This is what? Multiplicative inverse. How you get? By this identity. If a number, by adding you get an identity, then it is called as inverse of inverse. So inverse, like additive inverse, like you have learned in that function matrices also, right? Right, A into B is equal to I, then A is inverse to B, B is inverse of A, isn't right? So likewise, if two functions are there, if they are inverse to each other, f of x and g of x, they said as f of x and g of x are inverse to each other, then f of g of x will be equal to x. Function का rule क्या है? F circle g is equal to x or g circle f is equal to x. They are called as what? They are called as inverse to each other. पता है ना? ये y में ले सकते हैं, x में भी ले सकते हैं सर. अब g सर्किल f भी ले सकते हो. g सर्किल f of x is equal to what? x. This is a rule of inverse function na? हाँ or not? Or f circle you can write this is also f circle g of x. If I take x I should get x. If I take y I will get y. So this is equal to x. Then this is inverse. F and g are inverse to each other. F circle g is equal to x. Then f and g are inverse. Rule for inverse function. Correct. So if I break this one, f break g of x is equal to what I am going to get here, x. If I differentiate this both sides, what I going to get here, f dash of g of x, okay, into differentiation of this. So g dash of x is equal to differentiation of x 1. I informed you, this is a chain rule I applied. Differentiation you will understand when I start differentiation topic. Here I applied chain rule, right? Suppose you have, I told na, e power x square. What is the differentiation of this? E power x differentiation first, then x square differentiation, right? I told you sin 2x is there. What is the differentiation of sin x? Cos x. And differentiation of 2x is what? 2. So into 2. So 2 cos 2x is the answer. Likewise, if I differentiate f of g of x, then I get f dash and f dash of the function, and inside one again differentiation g dash of x is equal to x differentiation 1. It means f dash of g of x value is equal to 1 by g dash of x. That is only I gave yesterday. F dash of g of x is equal to 1 by g dash of x. Right? Next. Over, done. All points over. What are remain here? In last I told you, in general f circle g, g circle f not be equal. Means I told you na, f circle g is not equal to g circle f. They are not commutative property. They don't hold the commutative property. Composite functions are not holding. But they are going to be associative property. They are going to hold the associative property. But the commutative property, they don't hold it. But some cases, a specific reason, he said that is only here. In general, f circle g, g circle f are not equal. But if they are equal, suppose, if they are equal, then majority of the cases, either f and g are inverse to each other. Means f inverse is g, g inverse is f. F inverse is g, same, and g inverse is also f. Both inverse are same. At that particular time only, this is possible. What is possible? F circle g is equal to g circle f. Actually, there is not possible at all. It's not holds the commutative property. Like a into b is equal to 0. बोलते हैं ना अभी matrices में भी बोलते हैं ना, a into b is equal to 0, then a is equal to 0, or b is equal to 0, or ab is equal to 0. Cases like that. Same wise like this. If it holds like that. Or another case is said, or otherwise, at least one of f and g are identical functions. Means कोई भी एक identical means f of x x होना चाहिए या g of x x होना चाहिए, identical होना चाहिए. g of x is identity function. f and g both दोनों में एक identical होना है तो हो जाएगा. If both, so like here, you want to say that if f of x is x, f of x is given x, and g of x is given sin x, and you are finding this, then what is f circle g? F circle g will be what? F break g of x, and what do you get here? F of sin x, and f of sin x, if I substitute what in the place of x I substitute, I get sin x. Okay, if I do g circle f, if I do g break f of x, what is f of x here? F of x is x, and g of x is what? Sin x. Now see here, in these both cases f circle g, g circle f are equal. So f circle g, g circle f are equal, that will be at least one of them are identical. So one of the function is identity, then it holds. When it is possible f circle g, if they can ask this as a choice, multiple choice में पूछ सकते हैं. We know that F circle G circle F are not identical, they are not equal. But if it is equal, what is the rule? At least one of them should be identical or both of them should be invertible to each other. Both of them to invertible to each other or identical, at least one of them is identical, then only F circle G circle F are equal. Right? These are the properties. That's it. Over.